Hi there, welcome to this practice set on laws of exponents part 2. Please like and subscribe for more math help. Just super easy little buttons to click. Drop a comment or a question below, and please check out the many other videos and playlists we have on the channel. We've got playlists that focus on algebra tiles and focus on Desmos and factoring and all kinds of things. So please be sure to check out what else is on the channel. Now, without further ado, pause the video, work these problems on your own, and then come back and check your work. All right, now I mentioned in the lesson video for this that there is often more than one way that you can do these. And for the sake of time, I can't really do all of these problems multiple ways when there are different ways to do them. I'm going to kind of do them the way I see them. And what's important is that you land in the right spot and that you can justify all of your own steps. So if you get there a different way than how I got there, that's totally fine, as long as each of your steps is logical. Now, this first one, pretty straightforward. I think for this one, I was driving at the fact that you're not going to move the 2. So we've got this exponent of -5 in the denominator, and what that means is that factor moves to the numerator. So it's going to hang up out there with the 2, and it would just be 2x to the 5th. Okay, so there we go. All right, now next one, I think there are options for how you would want to do this one. What I see on this is I'm going to do first is just like with the one before it, I see this exponent in -2, and I'm going to kick that up into the numerator, which will effectively get rid of my denominator. So I will have parentheses 3x squared all to the 3rd times 2x all squared. And because I moved that up to the numerator, now the exponent is positive. Now I'm going to go ahead and this becomes like the problems from the previous set where we're going to multiply those exponents through. So we will have 3 to the 1 times 3, so that's 3 to the 3rd, times x. 2 times 3 is 6. We have the same thing happening right there. It's 2 to the 1 times 2 and x to the 1 times 2 as well. 3 to the 3rd power is 27. Then we have x to the 6th. 2 squared is 4. And I don't know why I put a different time sign in there, but there you go. And so we need to do 27 times 4, which is 108. Love that number. And then x to the 6th times x squared is x to the 6th plus 2, which is 8. Now, if you got something in there wrong, just note what it is. Common mistakes that I would see is saying 3 to the 3rd is 9. Okay, so student ends up doing 3 times 3 instead of 3 times 3 times 3. Other mistakes might be multiplying the exponents, because we just did a whole bunch of multiplying of exponents, and so a student says x to the 12th instead of x to the 8th. None of those are like huge mistakes, but they are mistakes, so you do want to fix them if you made them. And again, that's not the only way to do that problem. So there are other ways you could have gotten there, but you should have gotten there. All right, now this one I think is driving at the idea that you only move the stuff that has the negative exponents. And so what I see right here is the x to the -3rd. So that is going to take a journey down to the denominator. And the y to the -2 is going to take a journey up to the numerator, but everything else stays where it is. So the 4 stays put, the y to the 3rd stays put, and the 8x to the 4th all stay put. only move the things that have the negative exponents on them. So that means that in my numerator, I have the 4 and the y to the third. Those are still there. And they're going to be joined by a y squared. Of course, that will be a positive 2 now. In my denominator, I have the x 8 and the x to the fourth, and they are going to be joined by the x to the third. I have now in the numerator 4, and these are going to be added. So the exponent is going to be added. The factors are being multiplied there. But that'll give me y to the fifth over 8. X to the 4 plus 3 is 7. But I can do more here, and that is because 4 divided by 8 is 1/2. So my numerator would be 1y to the fifth over 2x to the seventh. And of course, you don't need to write the 1 there. So probably the final iteration of that for most people would be y to the fifth over 2x to the seventh. You can, of course, put the 1 there. And notice what you did wrong if you got it wrong. So common mistakes that I would see is maybe not simplifying the 4 over 8, or this happens a lot, subtracting the 4 and the 8. Because when we are doing a lot of these, we subtract the exponents. And so we will have, we get used to subtracting the exponents. And what students do is they end up subtracting the number part as well. But remember, it is division. So that is 4 divided by 8, which is 1/2, or like 4/8 of a pizza. Okay, you got pizza, 8 slices, you ate 4 of them, you ate half the pizza. So don't subtract that. So that's just a common one. Number 4, what I think, again, like just kind of going for different things when I wrote these problems, I was trying to go for the idea that the x, y was raised to the 5th power, but the 3 wasn't. And so we've got, like, in the numerator, stuff that's grouped and stuff that is not grouped, and to pay attention to what has the exponent attached to it. So I'm going to start off with dealing with that exponent there. And so the 3 is just hanging out. And of course, we've got that multiplication of the exponent through. So that'll be x to the 5th, y to the 5th. And then for the moment, I'm going to leave that alone. Now here you've got options, okay? And I'm going to go through it the way that I reason through it, and then I will, at least in this case, kind of back up. I tell my students this: I don't like subtracting exponents, so I just don't. And that is 100% personal preference on my part. I don't like subtracting them. Can you subtract them? Is that a viable strategy here? Absolutely. And so I will go through that. But here's what I do on this. Well, I think the first thing I would do here is I would take that right here, this y to the -2, and I'm going to move him up to the numerator, okay? And the issue here is with the x's. So the way I think about it is in my head, okay? So like we'll just kind of do like in my head. This is like a thought bubble, all right? I picture this and I kind of say to myself, I've got 5 x's on the top. I've got 4 x's on the bottom. I am going to cancel out a bunch of x's, and I ask myself, how many extra x's do I have, and where do I have them? So in this case, I have 1 extra x, and that extra x is in the numerator. Done. Okay, and so I would write 3x. I've got 1 extra x, and it is in the numerator. And then y to the 5th times y squared would be y to the 7th. And I really, truly do that in my head. I don't go through that. Now, another way, though, of doing this problem. So again, I said I wasn't going to do like all the problems multiple ways, but I think we do need to discuss this a little bit. Somebody might have done this where they recognize that we are dividing like bases. And so they would say, okay, I subtract exponents. So they would say x to the 5 minus 4, and they might not even write it out. Okay. And then they would do the same thing here. They would do 5 with the y's, 5 minus -2. Now, I think you can tell right off why that is maybe not like the thing that your teacher would tell you to do. So I would tell my students, just, move those negative exponents to where you don't have them anymore. And then you don't have to deal with like subtracting a negative, because a lot of students are just going to say 5 minus 2. They're not going to do 5 minus -2. But from here, we have x to the 5 minus 4. That would be 1. And then right here, 5 minus -2 is the same as writing 5 plus 2. And so x to the first power is just x, and 5 plus 2 is 7. And you can see that like that, yes, that also gets you to the same place. So which one of those ways you want to do it is entirely up to you. I kind of discourage my students from subtracting the exponents, and I personally don't like doing it. But there's just arithmetic errors that can come up, especially when you're dealing with negatives or a negative minus a negative. It can get not as much fun. So for the remainder of these, I'm going to really reason them out the way I would do them, and you are free to love that or flush that, like whatever you want to do. All right. Okay, so we got a lot going on here. So we've got in the numerator an x squared that I'm going to rehome down in the denominator. And in my denominator, I have a y to the -1 that I am going to rehome. Could I do this using a subtraction of exponents strategy? Yes. Okay. However, not until I deal with those parentheses. So let's just get rolling on this. So I'm going to have 27 y to the 6 because we're moving the x, and then I'm going to move that y to the first upstairs. And then in my denominator, I have 3x all to the third. The y has been rehomed, but the x to the -2 is now coming down. Let's go ahead and we can combine some steps here. So y to the 6 times 1, that would be 6 plus 1. So that's y to the 7th. And then down here, I'm going to have 3 to the 3rd, x to the 3rd, and then I have the x squared. Numerator will keep the same for the moment. 3 to the 3rd is 27, and x to the 3rd times x squared is x to the 5th. And then 27 divided by 27 is 1. And that leaves me with y to the 7th over x to the 5th. Could you have gotten there other ways? Yes, absolutely. Could you have combined some steps? And if I were doing this one completely on my own and not actually trying to explain the steps and the reasoning to like the World Wide Web, then I would have probably dealt with this in this step instead of taking its own step to do it. And because I know that 3 to the 3rd is 27, I probably would have jumped to like 27 there. So I would have probably done this in 2 steps instead of in 4. But again, yeah. Now, that rational exponents, that's what I needed to put. And division. I'm making some notes myself for what to put in the description boxes. So this is 4 to the 1/2, and since I'm going to do it for the lesson video, I'll try to remember to do it for this video as well, is to link if you need a review on that. 4 to the 1/2, though, is the same as the square root of 4 to the first power, which of course is 2. Okay, just a square root of 4, which is 2. So a little bit of a refresher there. Like, ooh, yeah, that's a 2. And then what else do I have going on? I'm going to take this, and we're going to rehome that in a denominator that did not exist before, but we'll put it there. And now I'll go ahead. Now, I think you can make a good case for this is simplified. I usually like to get each factor like independent. So we have x to the 3rd, y to the 3rd on that instead of xy all to the 3rd. But I think that's a debatable. As I said in the lesson video, always follow your teacher's instructions for how they want you to leave it. And again, if you're in a upper level class, like a calculus class, you might want the negative exponent there. Okay, you might want the negative exponent exponent if you're going to take a derivative with it, because you'd rather deal with that than deal with the fractions. Um, this one is hopefully not super difficult. So we've got x to the -1, and we can rewrite that as 1 over x to the first power, which of course is just 1 over x. And that, it wasn't intended to be super tricky, but it is intended to point out that one of the main uses of negative exponents is to get rid of fractions. Now, it's not usually considered the simplest form when you are simplifying these expressions, but like I mentioned in calculus, a lot of times you do want to just get rid of a fraction. So if you've got a fraction there and you don't want the fraction, you can get rid of the fraction by just taking everything in the denominator and writing it as an exponent to like the -1, which is perhaps a useful thing to do. So, all right, over here, well, this looks lovely. I think I don't want to deal with the negative exponent. So what I'm going to do is take this whole thing that's raised to the -1/2, and I'm going to rehome that up in the numerator because yuck. So that'll be parentheses 16x squared y squared to the +1/2. Okay. Yeah, ouch. Because the idea of multiplying a negative fraction through, like, that doesn't appeal to me at all. So what will this be then? It'll be 16 to the 1 times 1/2, which is 1/2. X squared, so you're going to do 2 times 1/2, but 2 times 1/2 is 1. And the same there. And then remember that 16 to the 1/2 is a way of writing the square root of 16, which is 4. And then we don't need those exponents, so that becomes just 4xy on that. That is nicely simplified. If you look at that original problem, it looks horrible. But with just 3 lines worth of work and a tiny bit of scratch work, if you are a little shaky on the fractions, the rational exponents, like that simplifies very, very nicely. All right. What was I going on here? I think this one I was trying to throw in like the idea of having negative and positive exponents mixed together inside the parentheses there. Now what you can't do is take that x to the -3rd and rehome that down in the denominator, because it is protected inside those parentheses. And so we do have a bit of order of operations there. And it's like the same reason why when we have the negative exponent outside the parentheses, we're not changing the signs of the exponents inside the parentheses, because they're like kind of protected in there. So before we can really deal with the negative exponents, we do have to deal with the fact that that negative exponent is stuck inside the parentheses there. So let's go ahead and move that through. So we'll have 2 to the 1 times 2, which is 2 squared, x to the -3 times 2, which is -6, y to the 4 times 2, which is 8, all over y to the 8th. All right, so now I can do some stuff. What I can do here is now I can rehome this. Okay, so this is going to find a new home. But I also have this going on where I have y to the 8th over y to the 8th. So I usually think of that as anything divided by itself is 1, and so the y to the 8th is going to cancel with the y to the 8th. You could also do your subtraction of the exponents, so you'd have y to the 8 minus 8, which is y to the 0, and that would be equal to 1. Okay, so we can get that exponent of 0 rolled in here. So kind of pick your poison. 2 squared is 4. that x to the sixth is going to get rehomed, and the y to the eighth is canceling out. And then the denominator, the y to the eighth that was there got canceled out, and we get the x to the sixth in the denominator. So that is actually a two-step problem, but you could have more steps than that. So if you did this, you might say, okay, y to the 0, and then y to the 0 is equal to 1. So that would be a very reasonable step for you to take as well. Okay, last but not least, so more of these fractional exponents. And the reason why I'm sticking with the exponent of 1/2 is because that is the most common rational exponent. Are there other rational exponents? Why, yes, you can check out my lesson on that. But the most common one is the exponent of 1/2, because the most common radical that we see is a square root, just an ordinary square root. And so of all the stuff with your rational exponents, if one thing only is going to stick in your head, then we would want it to be the exponent of 1/2. So I see that, and let's go ahead and rehome that in the numerator. So we will have 6 to the 1/2, and I'm going to rehome it like right next to the other 6 to the 1/2 instead of putting it down at the end there. And then we have this, and you are more than welcome to deal with this at the same time. So like I said, when I am demonstrating these problems, I do go a bit overboard. 2 times 3 gives me the 6, and of course that's 1 times 3, which is to the third. Now, right here, if you are multiplying like bases, then you are going to add the exponents. So this would be 1/2 plus 1/2, which of course is 1. And you do not need to write the 6 to the first power. So that simplifies there to 6x to the 6, y to the third. Now, another way you could reason that, because we're all about different ways of reasoning, is you could think of this. This is the square root of 6 times the square root of 6, which would be the square root of 36, which would be 6. So that would land you at the 6 as well. Not like one of those ways is not better than another way. They're just different ways that you could draw on the knowledge that you have of what these notations mean. So, all right, so that took us about 20 minutes or so to go over, and I hope that you found it helpful. Please don't forget to like this video if you found it helpful, to see the problems done out and get the explanation. Subscribe to the channel for more math help. Drop a comment or a question, and please check out the many other videos and playlists on the channel. Go on a deep dive and watch some videos on multiple choice questions. We have a playlist dedicated to that, and I hope that I see you in a future video.